Welcome to this lesson on pitch. Pitch is one of the most fundamental properties of sound that we experience every single day. Whether it's the chirping of a bird, the rumble of thunder, or the music we listen to, pitch plays a crucial role in how we perceive and understand sounds around us. In this video, we'll explore what pitch is, how it works, and why different sounds have different pitches. So, what exactly is pitch? Pitch is the perceptual quality of a sound that allows us to classify it as high or low. It's how our ears and brain interpret whether a sound feels sharp and shrill or deep and rumbling. Think about the difference between a whistle and a drum. The whistle has a high pitch, while the drum has a low pitch. This classification helps us distinguish between different types of sounds in our environment. Let's look at some everyday examples to understand pitch better. High-pitch sounds include things like a whistle, a bird chirping, or a soprano voice singing. These sounds feel sharp and bright to our ears. On the other hand, low-pitch sounds include thunder rumbling in the distance, the deep thud of a bass drum, or a deep voice speaking. These sounds feel heavy and powerful. These examples show us how pitch varies widely in the sounds we encounter daily. Now, let's understand the science behind pitch. Pitch is determined by the frequency of sound waves. Frequency is the key physical property that our ears detect and our brain interprets as pitch. When sound travels through the air, it moves as waves, and the frequency of these waves is what creates the sensation of pitch. Understanding this connection between frequency and pitch is essential to understanding how sound works. So, what is frequency? Frequency is the number of vibrations or cycles a sound wave completes in 1 second. We measure frequency in a unit called Hertz, abbreviated as Hz for example. If a sound wave vibrates 100 times per second, we say it has a frequency of 100 Hertz. The more vibrations per second, the higher the frequency. The fewer vibrations per second, the lower the frequency. There's a direct relationship between pitch and frequency. When frequency is higher, pitch is higher. This means sounds with many vibrations per second sound shrill and high-pitched. Conversely, when frequency is lower, pitch is lower. This means sounds with fewer vibrations per second sound deep and low-pitched. This simple relationship helps us understand why different objects and instruments produce sounds with different pitches. Let's explore some real-world frequency examples. A sound at 20 Hz is a very deep bass that's barely audible to human ears. Middle C on a piano vibrates at 256 Hz, producing a familiar musical note. A high-pitched tone at 1000 Hz sounds quite sharp and clear. The upper limit of human hearing is around 20,000 Hz, beyond which we cannot hear sounds. These examples show the wide range of frequencies we can perceive. Let's summarize the key takeaway from this lesson. Pitch is how we perceive the frequency of sound waves. It's our brain's interpretation of how fast or slow the sound waves are vibrating. Remember this simple rule: higher frequency equals higher pitch, and lower frequency equals lower pitch. Understanding this fundamental relationship helps us appreciate the science behind all the sounds we hear in our daily lives. Thank you for watching, and keep exploring the fascinating world of sound.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.